Alright guys, so it seems like some people are struggling with the mesh analysis problem 1C from the homework, so let's take a look at that homework. So this is the homework that's due on Monday, which is 2 days from now. To be honest with you guys, this problem is absolutely no different from this problem. It's literally identical. So if you solved A, you should have absolutely no problem with C. My guess is that you get confused because the voltage source is up here instead of over here, which I don't want. I don't want that because I want you to have deep roots, and I want you to be able to solve all kinds of problems and not get tripped up when something just moves. So let me just clarify that when you do mesh analysis, right, you draw your loops. So you know what, let me just, I guess nobody had any problems with A or B. At least the people that were talking in the group didn't have any problems with A or B. If you didn't have any problems with A, you shouldn't have any problems with C. The problem is identical. The way I taught it was, I personally like to start, wherever the voltage source is, so that I can go across the voltage source first to start my loop equation using KVL. So if I was doing this circuit, I would start below the 5 volt, come up and do this loop like this, and if I was doing this side, I would start below this 2 volt and come up and do this equation going counterclockwise. I would do the exact same thing if I were doing this circuit. I would start below this 3 volts, go up and around and go clockwise in this loop, and then I would start at VC here and go in this clockwise direction also for this second loop. It's going to give you 2 equations, 2 unknowns in both cases, and you just have to do the algebra. I definitely hope no one's struggling with the algebra. If you are, we can obviously set aside some time in my office hours, or like I said at the beginning of the semester, we could potentially do some sort of algebra review outside of class. But I can't afford to spend class time going over algebra in any kind of detail. So hopefully those aren't the problem. I'm going to work some sort of example here. I'm not exactly sure what I should do without giving this one away completely. I would like to, let's do something like similar to C, but not exactly C. So let me draw something. I just want to show you that it's the same thing. Hopefully I don't come up with some absolutely ridiculous problem here. Alright, let's go to my camera. So I set up my circuit to look like this, and I'll call this 3 volts, 2K, 1K, let's call this 2K, 3K, and then 0.5K. Alright, so that's my circuit, and let's say I want to find this voltage here, Vx. That's what we're trying to solve, and we're going to use mesh analysis because that's what the problem calls for. Let me try and... There we go. Look at that. How clean. Looks wonderful. Alright, so I'll define my currents. Like I said, you guys, you can define your currents however you see fit, however you'd like. In this case, I'll just define this one to go, what is that, clockwise? Yeah, clockwise. And just for the sake of it, I'll define this one to go clockwise as well, just so you can see some kind of different look. We'll call this I1 and we'll call this I2. And I like to go around the circuit and put the pluses and minuses across the resistors so that I know basically if I'm going across this 2K, I know my I1 is flowing down, so on this side, put my plus to minus like that. I go like that, and then I go like this, and that, like, again, guys, that's just telling me the direction in which voltage is dropping based on how my current is defined. That's not necessarily telling us that that's actually how voltage is going to be dropping in the circuit, so I don't want you to think I'm doing any magic or making any crazy predictions here. I'm just defining my higher to lower potential across these resistors based on the direction that I defined in my current. It's all theoretical until we solve for it, but it's going to work out no matter what we do. That's the great thing about mesh. So again, this one's plus to minus is going that way, and then on this side it's this way. So you don't even have to draw the pluses and minuses. I just like to do it. All you have to do is keep track of what voltages are dropping across which resistor. So let's go ahead and solve this problem using mesh. We're trying to find Vx, and so I'll do an equation for this left side loop now. You can pick any node you want to start. So I'm going to pick this node right here because I like to go across voltage sources first, but you do not have to do that. So when I go across the voltage source, right, I'm going up by 3 volts. So I go ahead and write plus 3 volts, right? Now I go across this 2K, right? I'm going in the direction of the current. That's another thing to keep in mind. You have to go in the direction that you define the current when you write the loop equation. So I'm going in the direction I write the current. The current that's going to flow through this 2K, since I have I1 coming down and I2 going up, it's going to be I1 minus I2. Because they counter each other. They basically conflict. And my brother just turned on the shower, and it's going to be incredibly loud, and I'm really sorry, but I'm sure you can still hear me fine. Anyways, okay, so basically I'm dropping across this resistor, which means I'm going to subtract minus, and it's going to be, like I said, minus I1 minus I2, and that's going to be times 2K. And then I get to this 1K, and that's going to be minus I1 times 1K. And then I get to this 2K, and that's going to be minus I1 times 2K equals 0. Alright, so our first equation is completely done. If we want, we can, group the like terms and stuff and get it to look a little bit cleaner. So I've got 3 volts minus I1 times 2K. This minus and minus give me a plus I2 times 2K minus I1 times 1K minus I1 times 2K equals 0. I can group all the I1s together, so I've got a 2K, a 1K, and another 2K, so that's going to give me 5K. So I'll drop the plus now because we know it's positive. I said minus I1 times 5K, and then I've got a plus I2 times 2K equals 0. So there's my first equation. Alright, so now I need my second equation. You know what, let me box it. So now let's do equation number 2. That's the other loop. Now in this loop, I don't have any voltage sources, but that doesn't mean I can't make a loop here. I can still make a loop based on just the voltage drops that are in the circuit. Okay, so I'll start at Vx and I'll just go around the loop this way. Again, it doesn't matter where you start. I could start here, I could start here, I could start anywhere I want. Wherever you prefer to start, it doesn't matter. It's all just going to be one big equation, and the order of the terms don't matter. So let's start at Vx, and we'll go across this 3K. So I go across that 3K, I get minus I2 times 3K. I go across the 0.5K, so I get minus I2 times 0.5K. And then I go across this 2K, and I get minus. And now in this case, we're going in the direction of I2, so we're going to say I2 minus I1. I think this may have been a problem for some people. Times 2K. So if we're going in the direction of I2, then the current that's flowing, based on our definition through this resistor, is I2 minus I1, because we're going in the direction of I2 when we're trying to define this equation. So the current that we see going this way is going to be this current minus whatever this current is, right? Well, when we were over here, we're going this way, so it's going to be this current minus whatever that current is. So that's why we get an I1 minus I2 in the first equation, but we get an I2 minus I1 in the second equation. Okay, and then there's a few terms we can combine here. So we've got minus I2 times 3k minus I2 times 0.5k minus I2 times 2k, and then plus I1 times 2k equals 0. And now we can group the 3k, the 2k, and the 5.5k, so we get minus I2 times 5.5k plus I1 times 2k equals 0. Alright, so now we gotta do a little bit of algebra. We've got our two equations, we've got our two unknowns, right? Our two equations are here, boxed, and our two unknowns are I1 and I2, and that's what we're trying to find. Okay, so let's switch colors and do a little bit of algebra. So basically this equation's smaller, so I'm just going to start here, and you know what, let's just solve for I1. Why not? So basically I'm going to take this term and add it to the other side, so I get I1 times 2k is going to be equal to I2 times 5.5k, right? And so now what I'm going to do is divide both sides by 2k, and I get that I1 is equal to I2 times whatever 5.5 divided by 2 is. It's probably like 3.125 or something. Or 3.25 maybe? 2.75. Oh yeah, okay, yeah, sorry, my mental math is off. 2.75. And that's not k, right? That k is gone. The k is canceled, so it was literally just 5.5 over 2. So whatever I2 is, multiply that by 2.75 and you get I1. So that's what this equation is telling us, right? And now what we can do is we can take this I2 times 2.75 and plug it in for I1 in my equation, and now I have an equation that's just in terms of I2, and I can solve for I2. So let's go ahead and do that in another color. Let's do teal, because I like teal. Teal's my favorite color. Maybe I'll put that on a quiz or a midterm and extra credit it if you guess my favorite color, because that means you actually watched this video and I'll be very pleased. Just kidding. That's not fair to the people who didn't need help with this problem. Anyways, alright, so let's plug this in. So we've got 3 volts. We're plugging this, right, I1, which is now in terms of I2, into this equation for I1. So I'll write equation 1 again here. So I've got 3 volts, right, minus I1 times 5k, so my I1 is now I2 times 2.75. And that's now multiplied by 5k. And then plus I2 times 2k equals 0. So what's 5k times 2.75? So 5 times 2.75 gives me a 13.75. So 3 volts minus I2 times 13.75k plus I2 times 2k equals 0. So basically I can go ahead and get all the I2s on one side by themselves. So let's say 3 volts equals, and now I'm adding this term over to the other side, and I'm subtracting this term over to the other side. So I basically get I2 times 13.75k minus I2 times 2k. That's going to give me a 3 volts equals I2 times 11.75k, right? And now I divide both sides by 11.75k, and that's going to give me my I2, because these cancel, so I should get a reasonable answer. Let's see what's 3 divided by 11.75. I get 255. Is that 0.255? Yeah. So this is going to be 0.255 milliamps. That's my I2. Beautiful. All right, so I've got an equation for I've got I2 basically, and I have an equation for I1 in terms of I2. So I just take I2, multiply it by 2.75, and that gives me I1. So let's take that value, times 2.75, and I get 702. Okay, so that's 0.72. 702. Our area code, nice. Milliamps. Alright. So now, I've got I1 and I've got I2. So I can go ahead and solve for Vx if I wanted to. And I do want to. So basically, I1 flows down through the resistor, right? And I2 flows up through the resistor, which means my current flowing through the resistor, the 2K, is I1 minus I2, or 0.702 milliamps minus 0.255 milliamps. And that's going to give me, let's see, that gives me 0.447 roughly. 7 milliamps. Okay. And so now if I take that current, which is the current flowing through this 2K resistor, right, and I multiply it by 2K, that should give me whatever Vx is, okay? That's just using Ohm's law, right? The current through the resistor multiplied by, we know this is 0 volts because this is ground, right? So the current through the resistor multiplied by 2K gives me the drop across the resistor. I know this is 0, so Vx is whatever I times R is, right? So let's say Vx now is equal to 0.447 milliamps times 2K. Basically just going to be double that then, and it's going to be volts, so it's 0.893, okay, so 0.894 volts basically. .894. And we're done. We found Vx. And now you could find other voltages in the circuit if you wanted to, because you have all the currents, you have Vx, you know. If I take this Vx and then I know that this drops by 3 volts and this is going to go negative, and then blah, 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 all the old stuff. So just to make sure that I didn't do anything wrong, let's go ahead and throw this exact circuit in Spice and see if we get something in the order of 0.894 volts for Vx. Go ahead and open up Spice. Let's make a new schematic. And we've got a voltage source that looks something like that. Got some resistors. One there. One there. We've got one here. We've got one here. And then we've got one over here. And then we'll connect. This is a lot harder without a mouse, guys. I'm using my trackpad. I definitely recommend using a mouse when you use Spice, because this is not fun. Alrighty, we're almost done. Just want to make sure that my Vx is correct, because if it's not correct, then I need to trash this whole video, because I'm not going to sit here and try and find my mistake. Hope everybody's having a good weekend so far. I don't know who's watching the Super Bowl tomorrow, but if you are, my opinion is that the Rams are going to win. I did not bet. I just think the Rams are a better team. I know a lot of people think that the magic is with Joe Burrow and the Bengals, and very well could be, so that's why I didn't bet. Alright, we've got it set up. I'm expecting Vx to be 0.894 volts or something close to that, so let's hope that that's the case and run it. Beautiful. 0.8936, that's exactly what my calculator had. So there you go. So that's a good mesh example. Basically, this problem is very similar to the problem on your homework. Also very similar to problem A. They're solved in the exact same fashion. So my guess would be, since I'm not exactly sure what people messed up on, my guess would have to be that people either messed up on, when you're going in this direction, you have I1 minus I2 flowing through the resistor in your equation, and when you're going for this loop, you have I2 minus I1 that will make a difference, right? That will make a difference. One of your signs will be off, and everything will get thrown off, and all the algebra will be thrown off. You can tell this method's very algebra intensive, and it's very important that your algebra is, sharp in order for you to solve these problems using mesh. Mesh is not going to go away. We're going to have a mesh problem on the midterm, on the final. Your quiz on what's today? Your quiz on Monday is a mesh quiz, so just so you know. And yeah, if anyone has any questions about this or anything I did here, feel free to ask the group. I will be watching the Super Bowl tomorrow, but that doesn't mean I won't be available to answer questions. So please let me know if you have any questions. And yeah, I'll see you guys Monday.